Have you ever wondered what keeps your feet planted firmly on the ground? Why don't you just float away when you jump? The answer is a force so familiar we often forget it's even there. It's called gravity. Think of it as a giant, invisible hug that the Earth gives to everything on it, including you, your house, and even the air we breathe. This constant pull is what gives objects their weight. It's not magic, it's physics, and it's a fundamental force that shapes our entire universe in the most incredible ways. Gravity is the natural attraction between any two objects that have mass. And what's mass? It's just the amount of stuff an object is made of. The more stuff or mass an object has, the stronger its gravitational pull. The Earth has a whole lot of mass. It's a massive ball of rock, metal, and water, so its gravity is super strong. That's why when you drop a pencil, it doesn't just hover in the air, it falls directly to the ground. The Earth is pulling the pencil toward its center, and the pencil is pulling the Earth too. You just don't notice it because the Earth is so much bigger. This invisible pull is always at work, all the time. It's the reason an apple falls from a tree, why rivers flow downhill to the sea, and why you feel a little heavier after a big meal. You've added more mass. Every single object with mass in the universe pulls on every other object. That means you have your very own gravitational field. Right now, you are pulling on your computer, your chair, and even the moon. Of course, your pull is incredibly tiny compared to the Earth's, so you won't see your pencil suddenly fly into your hand, but the force is there, a silent testament to your place in the cosmos. Every time you lift something heavy, you're fighting against Earth's gravity. When you throw a ball into the air, you give it an upward push, but gravity immediately starts pulling it back down. To understand how gravity works over vast distances, let's do a thought experiment. Imagine a giant, flat, stretchy trampoline. This trampoline represents something called space-time, the fabric of our universe. Now, if you roll a small marble across this flat trampoline, it will travel in a perfectly straight line. It has no reason to change its path. But now, let's place a heavy bowling ball right in the center of our trampoline. What happens? The fabric of the trampoline sinks and creates a deep curve, or a well, around the bowling ball. The heavier the ball, the deeper the curve. This is exactly what massive objects like the Sun and the Earth do to space-time. A famous scientist named Albert Einstein realized that gravity isn't a mysterious pull, but is actually the result of massive objects warping or bending the fabric of the universe around them. It's a mind-bending idea, but this visual helps make it much clearer. Now let's roll that same small marble across the trampoline again. This time, as it gets near the bowling ball, it won't travel in a straight line anymore. Instead, it will follow the curve in the fabric created by the bowling ball's weight. If you roll it with just the right speed and at the right angle, the marble won't fall directly into the center. Instead, it will start to circle around the bowling ball, caught in the dip. It's not being pulled by a rope. It's simply following the bent path in the fabric. This is what we call an orbit. The marble thinks it's going straight, but the curved space makes its path a circle. This is precisely how our solar system works. The Sun is the giant bowling ball, creating a massive dent in the fabric of space-time. The Earth and other planets are like the marbles, rolling along the curved paths created by the Sun's immense mass. Here on Earth, gravity's job is simple: keep everything down. But out in space, gravity is the master choreographer of a grand cosmic dance. It's the force that pulls gas and dust together to form brand new stars. Once a star is born, like our Sun, its powerful gravity creates that dip in space-time we talked about, gathering planets, asteroids, and comets into a solar system. Each planet is held in a stable orbit, a perfect balance between its forward motion and the Sun's gravitational pull. If gravity were suddenly switched off, the Earth would fly off into space in a straight line, leaving the warmth of the Sun behind forever. The same principle applies on a smaller scale with moons. Our moon orbits the Earth because it's caught in Earth's gravitational well. Just like the Earth orbits the Sun, the moon is constantly falling toward the Earth, but it has enough sideways speed to keep missing it. This cosmic balancing act is happening all over the universe. Jupiter, the largest planet in our solar system, has dozens of moons all held in its gravitational embrace. Gravity is the architect of these beautiful, predictable systems, from moons orbiting planets to planets orbiting stars. But gravity's influence doesn't stop there. It also groups stars together into enormous collections called galaxies. Our own galaxy, the Milky Way, is a swirling disk of hundreds of billions of stars, all held together by their mutual gravitational attraction. And it gets even bigger. Galaxies themselves are pulled together by gravity into groups called clusters, and those clusters form even larger structures called superclusters. When you think about gravity holding entire galaxies together, you might assume it's the strongest force in the universe. But here's a fun fact: it's actually the weakest. Compared to the other fundamental forces of nature, like electromagnetism, the force that holds atoms together and powers magnets, gravity is astonishingly feeble. Think about it. You can overcome the entire gravitational pull of the planet Earth with a tiny refrigerator magnet picking up a paperclip. The magnetic force of that little magnet is stronger than the gravity of a whole world. This weakness is why you don't notice the gravitational pull of everyday objects. Your desk is pulling on you, and you're pulling on your desk, but the forces are so minuscule that they're completely swamped by other forces. It's only when you get an object with an immense amount of mass, like a planet or a star, that gravity becomes a major player. It's a force of quantity. A single atom has almost no gravitational influence, but gather trillions upon trillions of them together, and you can build a world. Despite being the weakest link, gravity has one huge advantage over the other forces. It has an infinite range. While other forces work over tiny subatomic distances or require specific conditions, gravity affects everything with mass across the entire universe. And for our final surprising fact, did you know that gravity travels at the speed of light? If the sun were to magically disappear right now, we wouldn't know it for about 8 minutes. We would continue to orbit the empty space where the sun used to be, held in place by its lingering gravitational field. Then, after 8 minutes, the time it takes for light and gravity to travel from the sun to us, the Earth would suddenly fly off into the darkness. Gravity isn't instantaneous. Its effects ripple through space-time at a finite speed. So the gravity we feel right now is actually from the sun as it was 8 minutes ago. Now that is a truly cosmic thought.